There's that slide. Anybody?
Can I copy the first one?
This is the first one? Okay. No, that's this. That's this one, right?
Mm-hmm.
Sure.
Wait, so what was the answer for
Number what?
number 2?
What'd we say for 2, guys?
0.
It was a decimal. We're looking for a rate, so it was a decimal answer, right? 0.54? Okay.
It was
It's
0.054.
0.054.
For what? No, but like 11:45.
For how much time?
11:45. What was it asked for? 11:40.
11:40? So,
Downloads or like what was the question? Like 0.0.
no, they were looking for rate. That would have been degrees per minute.
Degrees.
Yeah.
Is this quiz for a grade?
Yeah.
Okay.
Everybody got everything down? You done, Allison? Pass them up. Allison, could you pick them up for me, please? All right, I'm going to start the lesson. Unfortunately, you're going to have to finish watching it online. It's already at Infinite It's Learning. So number 2 said that a pizza is removed from the oven. When it was removed, it had a temperature of 425 degrees, so it was very hot. After 15 minutes, the pizza cooled to a whopping 200 degrees Fahrenheit. Use a continuous exponential decay model to find the approximate decay rate. So we need a good formula for decay. The amount of heat we're going to have in the future is equal to the amount of heat that I start out with. E raised to the rate of change of the heat. This time, who was it? Was it Powell? Were you asking me about the negative?
Yes.
I'm going to put a negative now. Somebody tell me why. It's a decay. Now, let's plug in everything that I know, because I don't know R. But I do know time. What's time? How much time? 15 minutes. I do know how much the original, I can even put a little circle here to say that it's the original temperature, P sub naught, P sub 0. What is the original temperature when it comes out of the oven? For what? Exactly. What was the new temperature in the future? All right, let's plug everything in. Abraham said everything. He said the new temperature is 200. The old temperature is 425. E. Negative R, I don't know. Time, I do. It's 15 minutes. And when we're talking about cooling, we're always talking about the number of degrees per minute. So I'm okay with using 15 minutes. Now, this is a problem that could have been on your test last week. I got to solve it for R. What do I have to get rid of first?
The E.
No, you can't get rid of E first.
No, because you need got enough.
Somebody, what operation could I do to both sides?
Oh, divide
By what?
by 425.
Perfect. Divide both sides by 425 and get that number away from the E.
Oh, yeah.
So I don't know what 200 over 425 is. I could divide both by 25 and I get 4 out of 9. Oh yeah, 4 out of 9 is a good fraction. I divided both by 25s. Equals to,
0.05.
well, if you're going to use decimals, don't round them. use like 10 decimals.
0.0.
That's why I'm keeping 4/9. It's the exact. If you're using decimals early, your answers might be off. E raised to the negative r times the 15. Now, here's my question to you. Let's see who. Some of you guys got a good grade on your test last week. Prove it to me. How do I get rid of this base E? What is the inverse operation of an exponential function base E? To get rid of that base. What would I do to both sides? What's the inverse of exponential? Thank you. So if I ln both sides, ln this side, ln this side, and just to remind you, this now is a natural log of ln of e raised to some number. You could put that number out front now, properties of logs, but I don't really have to. What is natural log of e? It was in your notes on day 1 of natural log. You could use a calculator and type it in. Star, what's the natural log of e? Do you have a calculator? You have a calculator? Key in natural log of e for us. Of e. Help her, Esma. Show her where the buttons are. But I'd like you to get it done in the calculator, though. Esma, you're supposed to help her with the calculator, not just give her the answer. So it basically cancels out because, as I said, natural log of 4/9, this is equal to the negative r times the 15 natural log of e, and they figured out natural log of e goes to a 1, so it's gone. I'm almost done. What do I do to both sides right now? By what? By a what? How about a negative 15, so there's a negative in front also? Would that work, Chloe? You said negative 15?
Yeah.
Oh, good for you. Divide both sides by a negative 15. Out pops out the r because the 15 cancels, the negative cancels. So it looks like that cancels, that cancels, that cancels. R, here's your exact answer. Natural log of 4/9 divided by a negative 15. Would you like to have the approximate answer?
Yeah.
Key that in.
It's 0.
It's tough, yeah. It's just solving an equation, just like you took a test last week.
0.05. That's what I said.
I need at least 3 decimals.
0.054.
Wonderful. That's just a rate. It actually means degrees per minute, to be honest with you.
At the beginning, you could have just done, because I did negative 15 equals 200 over 425,
Yeah?
and then divided that by negative 15 by canceling.
Well, I don't know why you were dividing at that step because there's nothing.
Not yet, until I divided the 200 for 25.
Yeah, I know that, but I don't know what made you decide to divide by the 15. You had to understand that the natural log of e goes away. Somehow you had to know that. All right, next one. There's that slide. We got investment of $1,500. Well, then let's do it with me, Chloe. You spent a lot of time on that hard one. Invested $1,500 in an account with an interest rate of 6.5%. That decimal would be, what's a decimal of 6.5%? 0.065. Okay. So here, you think you got it? Formula is amount in the future. This is not continuous. This is compounded. It says that right here, meaning we're going to have the end number. Okay? Compounded means you are making interest so once a year, once a day, once an hour. So, and it's not compounded continuously. So it's compounded monthly. So what's N?
Over 12.
It's a 12. N is 12. So I go, A of T will equal to the amount I'm investing, $1,500, times 1 plus, I need my R. Oh, say it again. Point what? 0.065 divided by 12 raised to the 12. It's I'm going to put N. I'm going to put the N and the T. So I'm going to go 0.065, 0.065 T. That's it with T's. Now, how many years am I investing?
Wait, why did you put 0.65?
R. That's N. You're right. You got to catch the old man from falling. NT, not RT. So it's 12T, right?
Yeah, 12 times.
Thank you. There's more points for you when you send that message. I already said you get some today, right? No? Well, that's your first one? All right. NT, 12T. A of 12 equals to 1,500. I'm not going to do that math right now. I'm just going to let my calculator do the work. 12 times what? 12 times 20. Can we just key that whole thing in the calculator right now? I'm too lazy to do any mental math.
I got 5,484.
You think it's around 5,484 decimals?
Well, 0.67.
0.67.
Yeah.
Put a dollar sign. Did anybody else get this answer? Please, somebody make me proud. Yes?
Wait, I
Go.
got
Is it right or is it wrong?
16.
She got it back there.
You got it?
Sarah? Sarah got it.
Oh, what?
And I trust Sarah.
Never mind.
I trust Esma. Now, the second part of this problem. Same amount of money. How many years? Oh, it's hard. It's going to be a hard one. How many years will it take for the balance to reach $10,000? Why? Because I'm going to buy a used car. So I'm going to take that money that Grandpa gave me, and I'm going to see how long will it take for that bank to collect $10,000. But we're going to compound continuously now, which is what most banks do. It's really continuous. Formula is going to be the amount of money in the future equals the amount of money I start out with. E, since it says continuously, to the RT. What was my R again? Let's plug everything in. Let's go ahead and plug A of, no, I don't plug A of 20. What is the amount of money in the future?
Are you talking about rate?
Yeah, no, how much money do I want in the future? 10 what?
10,000.
10,000. How much am I starting out with? Was it 15,000 or 150?
We're starting off with 1.
It's on the paper, guys. Read the top line. What did it say up there?
Yeah, 1,500.
Yeah, well, and plus we wrote it over here on this problem, 1,500. That stayed the same. So we're investing 1,500. E, My interest rate, you say it was still 0.0625?
No, just zeros, like 0.65.
0.65. And how much time do I need? That's what we're trying to find out. Do you think this problem's any different than the last one we did? What number do I get rid of first? Divide both sides by? 1,500. Good job, Obed. 1,500. Can I do that in my head? 10,000 divided by 1,500. I know these two zeros go away. I don't know what. 100 over 15 reduces to 20 over 3, I think.
That's 20 over 3.
20 over 3 equals to E raised to the 0.065t. And aren't I going to do natural log again to both sides to get rid of E? Yes? That's how you get rid of E. Natural log both sides. That cancels out, leaving the natural log of 20 over 3 equals to 0.065t. What's my next step? Divide by the 0.065 on both sides. That cancels. This is your exact answer. Natural log of 20 thirds divided by 0.065. Could somebody be so kind as to tell me approximately how much time that's going to be? Give me at least one decimal place. If you're not careful, Sarah's going to beat everybody to the punch.
29.
0.1?
Well, if you round it off, it's 29.2.
Let's take the 29.2 years. So are you willing to wait that long to buy your used car? That's if you're not, see, here's the thing, you're not financing the car. You're going to pay the money and buy the car. What's that? Questions on either one of these problems? No? We're good to go? Last chance. There's that one slide.